Hello everybody and welcome to another visual pattern challenge. Here is our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of these purple cubes in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to express the number of cubes in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. Okay, so it looks like we have this three-dimensional shape here, kind of a tower of blocks that's growing from step to step. So my first question for you is, because it's three-dimensional, does this mean it's a cubic pattern, or is it a quadratic, or is it a linear? Can you tell just by looking at it? What's your sense? Well, let's see if we can count the numbers of blocks in each step and then analyze the numbers and see if we can get a sense of that. So I've got 1, 2, 3, and then this fourth one on the back sticking out here. So there's 4 in step 1, and then looks like 1, 2, 3. We got those 4 up here, and we've added, well, it's hard to tell if we've added 2 or 3. Does this back block continue? Let's move this and see. Yeah, so that back block is behind there. So it looks like we've added another layer of 3 there. Okay, so this would be 7 then here. And then I assume the same thing happens here, so another layer of 3, so that would be up to 10. What do you think now? Well, for step 4, I guess we're going to add another layer like this, and then the one in the back. So it would be another 3, so we'd have the 4 originally, plus 3 more is 7, plus 3 more is 10, plus 3 more is 13. So I'm thinking 13 in step 4. Let's go ahead and look at those numbers. So I'll put the step number in a chart and the number of cubes. So in step 1, we've got 4. In step 2, that's 7. In step 3, we have 10. And we're saying 13 in step 4. And if we take the difference between each step, 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3, we find that we have a constant. So this function is growing, this pattern is growing by the same amount every step. That makes it linear. So even though this is a three-dimensional shape, its rate of growth is linear. It grows steadily from step to step. And we can go ahead and use that equation for a line to model that, y equals mx plus b. And where the m is, that's where we're going to put in our rate of growth, which is this difference. So y equals 3x. That's the stem of our equation. And then we can figure out what the b is by trying it out with step 1. So we put in the step number for x. So y equals 3 times 1. And that would equal 3. This is supposed to tell us the number of cubes, but we have 4 cubes. So we're 1 short, so we just need to add 1. So y equals 3 times 1 plus 1, that's 4. Yes. So our equation then will also have a plus 1 in it. So our equation is y equals 3x plus 1. Let's test that with step 2. Y equals 3 times step 2, plugging in the step number for x, plus 1. 3 times 2 is 6, plus 1 is 7. Yeah, that's how many you have in step 2. And in step 3, y equals 3 times step 3 plus 1. 9 plus 1 is 10, and that's how many we have. So our equation is y equals 3x plus 1. Now to get step 43, we're just going to plug that in for x in our equation. So y equals 3 times 43 plus 1. And 3 times 40 is 120, 3 times 3 is 9, so that's 129 plus 1. So that is 130 cubes in step 43. Well, how did that go for you? Did you see that this was a linear pattern from the beginning, or did the three-dimensional shapes maybe lead you down a different path? Let me know. Thanks, everybody.